We're going to be learning our last lesson on polynomials. So today we're just going to go through one more situation, one more type of container that we are trying to maximize the volume of. So because we are going to be using our calculator, let's start off by clearing off our calculator. So second plus 712 to make sure that we reset everything. You're starting off from scratch. You don't need to worry about anything else. So we're going to start with this picture. So we have a trunk, and our trunk is constructed from a 20-inch by 30-inch sheet of material. So let's label 20 inches is this side, 30 inches is going to be this side, because obviously 30 inches is longer than 20. So this is the sheet of paper we're starting off with. First, our material is folded in half. So we're folding it in half along this line right here. So before it was 30, now each of these halves are going to be 15, right? Because half of 30 gives us 15. So each of these halves are 15. Now just like before, we're cutting out little squares that have a length of x from each side. And so what we're looking for is our length and our width for each of these. Okay, so let's start off with this side. So we have 20 minus, we have two of these x's being cut out, so really our length here is 20 minus 2x. And this side is 15, and we're also taking away two little squares. So this one is 15 minus 2x. So this one is going to be our length because this is longer. W is going to be 15 minus 2x. Now what's different about this one than the one before, so if we were to fold up the top and the bottom and put them on top of each other, this is what it would look like. This is why we're calling it a trunk. And notice for this one, so normally this would be our x, right, because our height is x, but now we have two on top of each other, and so our height in this case is actually going to be 2x. So again, we have our length, our width, and our height, and that is all we need to write our equation. So let's go over here. We're again trying to find volume since we're maximizing volume. Length is 20 minus 2x. Our width is 15 minus 2x. And then our height is 2x. So this is my equation for this function. And we're going to use this equation now to sketch and answer the rest of these questions. So for this, before we start finding our roots, let's label this. So our y value is our volume, again, which in this case is inches cubed. This one's a little bit different because x is neither our width, our length, or our height, right? It's none of those. So for our x, we're just going to label this the size of our cutout, because that's what we're cutting out. Each square is the size of our cutout. That's your x. So that's our inches. Okay, so let's solve for our roots. Our roots are going to tell us what our x, our 0 is going to be, and also what our x max will be. So for our roots, we have 20 minus 2x equals 0. So if we solve, we have 20 equals 2x, divide by 2 on both sides. X is 10, right? So we have a 0 of 10. If we do the same thing with 15 and 2x, we end up with 15 equals 2x. 15 divided by 2 is 7.5. And then, of course, this 2x just gives us 0. So our roots are 0, 7.5, and 10. So if we do a quick sketch, here's 0, here's 7.5, here's 10, and we know our graph is going to look like this, like our cubic function. And again, we only want the positive value, so we're only looking at the little hill, nothing else beyond it. And so this point right here, we know our 0 is going to be on 7.5. So we can actually already draw that. 1, 2, 3, 4, 5, 6, 7. So if this is 8, we know that our 0 is going to be on 7.5. So we already know when we draw our hill, it's going to end up here at 7.5. Now let's put this in our calculator so we could figure out the rest of this. So y equals, we're going to type in 20 minus 2x, 15 minus 2x, and then just 2x, all three of them in parentheses. Now let's go to our table to figure out what our y's are. So we already know our x's are going to go from 0 to 8 since we want something slightly bigger than 7.5. Let's look at our y's. So second graph, we're going to look at our table. Let's look at how high this number goes. So it's the biggest number it goes to before it starts going down. So if we look at it, it is going up, 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 and then down, down, down. The biggest number it goes to is 756. So we can pick any number bigger than that. We can do 800, we can do 900, so I think I'm going to just do 800. But yours does not have to be exactly the same. So now we can go to our window. So we know for both of our x and our y, it should always start at 0 because we don't want any negative width, length, or volume. So we're going from 0 to 8 since we wanted it to be a little bit more than 7.5. For a y min, now I'm going to go from 0 to 800, and I'm going to have my y scale go up by 200. And let's graph it. So this is what my function looks like. So it starts at 0, goes up, goes back down, and again, I already know that it's going to end here at my 0, 7.5 comma 0, because it's my root. Root is the same thing as 0. Now, just like before, we're now going to find our max. Second calc, we're going to go to number 4. Go all the way to the left of this point. Enter all the way to the right of this point. Enter, press enter again. And we have a maximum of 2.829. Let's round it. And then 758.076. Again, that 6 rounds the 5 up to a 6. So always 3 numbers after the decimal point. And now we are going to use these points to answer the rest of our question. So our domain, which is our x's left and right, starts at 0, goes until 7.5. Range also starts at 0, but goes up to our highest point is our maximum. We want to use our y value, so 758.076. Again, both brackets because these are closed points. There are no open points. What is the maximum volume that can be enclosed? So our max, we're looking at our max point. Volume is our y value. And so our answer here is 758.076 units inches cubed. What are the dimensions? So now we're still using our maximum, but we're using the x value. So our x value is 2.829. And now we're going to go back to our drawing to figure out our length, width, and height. So back to this sketch, we have the diagram. We have our L, so length is 20 minus 2x. So I'm going to be plugging in my 2.829 for my x. And so I have 20 minus 2 times 2.829. That gives me a length of 14.342 inches. Now my width, my W up here, is 15 minus 2x. Again, you're just going to plug in your x value from your maximum, which is 2.829. 15 minus 2 times 2.829, which gives us 9.342 inches. And then our height is 2x. So we're just going to multiply 2 times 2.829. And that's going to give us our height, which is 5.658 inches. And there are our 3 dimensions. Together, these 3 dimensions are going to give us our maximum volume. Yep.